Alright, so today we're going to be trying to solve this paper. This is Computer Science, May, June 2021. This is going to be paper 4, and this is the practical paper that we're going to be trying to solve. Alright, so without any further ado, let's get started. So this is a 2021 paper. Now for this, you are going to be needing the source files and the evidence.doc files. After the video is over, I'm probably going to be uploading the doc file. I hope my audio has been recorded. Yes, it is. So after the video is over, I'm probably going to be uploading the doc file, so you don't need to worry about that. Alright, so okay. So our first task is going to be going ahead and opening the evidence.doc folder. So I'm just going to go to my desktop where I've saved it. And then just open the evidence.doc folder. And then just make sure you enable editing. Alright, so now during the exam, you want to go ahead and fill out your center number and everything, all the details that's required with the question. And also, I would recommend to do one thing, which is you go to options, go to advanced, and then pasting from other programs. You want to merge the formatting because otherwise, sometimes the formatting of the editor kind of comes into view. Alright, so we don't want that. Next, I'm going to be using Visual Studio Code. You could use Python, you could use kind of whatever editor, ideal editor if you want to, and I'm going to be coding in Python, so if you are following a different language, then probably a different video for that, some of it, but for today, Python. Then I want to go to new and open folder, and when I go to open folder, in my case, I'm going to go to desktop, then the folder. So in my case, my text file, that's going to be the file that you're going to read, and the question is in the 2021 folder, so I'm going to select the folder. Once the folder is selected, I should be seeing all these three and treasure chest.txt because that's the file that we're going to be using for this exam. Alright, so we want to go and be able to kind of see that. Alright, so open the evidence.document and then obviously it's you want to go ahead and save it to the following format as instructed by the question paper. So the question has stated us a few of the following data that we want to keep in mind. The question has stated that a class, what kind of highlight? I don't know, for some reason. So a class declaration can be used. So we want to go ahead and use this data. So class declaration can be used to declare a record. A list is an alternative to an array. So in this case, a list is an alternative to an array. So Python doesn't actually support lists directly, nor does JavaScript, as far as I'm aware. I'm not aware of Visual Basic because I don't use it. So yeah, a list is an alternative to an array. Source file is required for question 3 only, and they will give you the name of the source file every single time. So make sure you check it during the exam. Now it says that each item is linked with the type node and a field data, which contains the data and the next node. And the current contents of the linked list are where the start pointer means it's the start of the linked list. So as you can see, it's the start index of the linked list, which contains the start data. And the empty list, okay, so the empty list is where the list is empty, right, in the linked list. So we can establish a few things from here. So start pointer is basically start of, of the list. And we can also identify that empty list is start is the start of where the linked list is empty. So we can deduce these two data from the question, right? We want to go ahead and deduce as much data as possible. Can I change the color of this because the question paper is also kind of black? Yep, I can. So this is the start of the list and empty list, obviously. So I'm also going to change the color real quick. Okay. So once that's done, okay, we want to go down and read it. So first, so we're seeing that the type record of type node is being, and the question says class declaration can be used to declare a record data type. So type node is given. So let's go and start coding. So we want to put a record data type, which is going to contain data. So this is important. It's going to contain data, and it's going to contain next node. Now, in this particular year, the question paper never specifically mentioned that Python, when you're using Python, you want to include declarations using comments. But from the following years, the question papers actually explicitly mentioned that we need to kind of use a common declaration if you're using Python. So for this purpose of the video and of the question, we're going to ignore it. Save your program as question one. So you want to save it according to the questions. I'm going to right click on new file, and the question says question1.py. Question one. Okay, let's close this up. So I'm going to zoom in slightly. So I want to go ahead and put a class declaration. So it's going to be class, which is named node, right? This is according to the question. Class node. Then declare data. So in this, we're going to have init, which is going to be our constructor. Let's raise this. So just name it data parameter and next node parameter, and then self. This should be public, not private. So we want to go and write just self.data, data p. You could use private attributes, but again, you need to probably write get and set methods for it. That's going to be making it difficult. But if you want, you can do that. It's totally up to you. So once this is done, this is the code that we want to go ahead and paste into the evidence document. So let's go ahead and put in the evidence document right here. Make sure you remove the italics and immediately save your code. All right, so let's move on to the next part. All right, so where's my question? Right here. All right, no. So again, after this has been done, write the program code for the main program. Declare a 1D array of type node with the identifier linked list. So that's going to be your identifier in this case. So the identifier is linked list, which is of type node, and declare the pointers. Okay. Initialize with the data shown on page 2. So we need to initialize this with all the data shown here. And also initialize start pointer and empty list. Alright, so basically we want to go ahead and declare linked list, and this is of type node, right? This is important that you include these with comments for Python. Then we want to append the linked list with these following data and nodes. So first of all, okay, so I would like to go ahead and do a split screen real quick so that it makes it a little bit easier for me to kind of copy the data. Okay, so over here I'm going to go for linked list dot append, and I want to name it node 1, 1. All right, so just to make stuff easier, let's copy this real quick. So you've got 10 data, so 1, 2, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then we want to just change these values over here. This is 5, 4. Then we've got 6, 7, 7, -1. Now I think -1 here is the null pointer of the linked list in this case. Then we've got 2, 1, 2, 2. Oh wait, I can see it. Oh wait, I'm gonna do the 2's again. So this should be 0, 6. Then this should be 0, 8. You can put the space or not. Let's just put it. It looks nice. Then we've got 56, 3, followed by we've got 0, 9, followed by 0, -1. Alright, and we also want to initialize the pointers according to the question. So again, start pointer is 0 and empty list is equal to 5. So this is the code for the entire part 2. So let's just go ahead and append this 5, sorry, and move the italics and paste. This is for this question, right? All right, so I want to go back to being full screen because it makes it easier to write the code, right? All right, so let's move on to part C. The procedure output nodes take the array and start pointer as parameters. So we want to highlight these parts of the question, which says it takes the start pointer as parameter, uh, and it takes the array as parameter following next node values. Okay, obviously. So these are the two important things following the next node value, right? Okay, so let's move on to the code. So first of all, this is def output nodes. So it takes the array as the parameter. So we're gonna write, just put a regular name over here, array, and we got the start pointer as parameters, right? And then from this, we can say that current. So I want to go ahead and put a local variable that kind of updates its pointers until, like, it reaches the end of the list, right? And it updates the value based on the next pointer. So I'm going to call that current pointer, or let's just call it next pointer. Like, makes more sense. So it starts off from the start pointer, and while next pointer is not equal to -1, because that's what indicates my null pointer, as you can see right here. So while next pointer is not equal to -1, we want to go ahead and print out array next pointer, the data of the array. And we want to update next pointer with the next node value of the current linked list that's being pointed to. So in this case, the array is the linked list, next pointer dot next node. So why next node? Because we have said next node over here, right? So that should be pretty much it for it. So I think that's going to be it. So def output nodes. This should be the code pretty much, if I'm not wrong. So let's go ahead and paste it. Well, we're gonna find out if we have any errors once that's once we're running the code. Now we do want to go ahead and during the exam, it's best if you test them. So I don't need this. I'm just gonna collapse this a little bit. So what I want to do is I want to just call output nodes with linked list and start pointer. Oops. So I want to call it with linked list and start pointer, right? Let's see what comes out in the terminal. There you go. Nice and smooth. You got our output that we wanted. So if you can, it's best to test the code, okay? And then remove it later on. Edit the main, oh, there you go. And it's to take a screenshot. So it already asks me to kind of do that, right? So in my case, it's Python. So all I need to do is just copy this single line. If you were doing it in Java, then I'm really sorry for you. So just the single line. There you go. Okay. Undo this. Copy and paste a screenshot. Okay, so it just asked me to call it, but it wants a screenshot of this output right here. So what I want to do is just Control Shift S and then just take the entire photo of the terminal to prove to them that yes, I have ran the code as required. If you're in Windows, obviously most laboratories are going to give Windows. It's Control Shift S. For a Mac, I think it's Command Option Shift F4 or 4, I think, just. But you gotta kind of Google the shortcut for Mac. I don't use a Mac, so I don't know. So yeah, just paste this. To make it look a little bit nicer, probably you could go ahead and make it slightly smaller so that it's kind of on the first part. And then kind of paste it. Alright, so let's move on to the next part of the question, which is this one. The function add node takes the linked list. Okay, so it takes the linked list and pointers as parameters. So it takes the linked list and pointers parameters and adds it to the end of the linked list. The function and the next level updates and returns true. So if it is done, it returns true, else it returns false. Okay, so is there any other requirement? Takes the linked list and pointers and input the data. Okay, so it asks me to input the data, right? So in the short answer, okay, in the short way, what we have here is we take the data, okay, we take the data, and we have an empty list, right? So you've got empty list right here. So we've got empty list. So we've got the data over here, and the data is being pointed towards nothing. Let's say so that's the null pointer, the data. So what we want to do is we want to go ahead and point empty list. Okay, so let's say we have the end, the last part of the linked list, right? So how do I delete? Oops, sorry. Oh crap. Oh, okay. I can undo it. I can undo. So what we have over here is our previous data, right? So what we want to do is this data, okay? This data is going to be pointing towards, it's going to be pointing towards, okay, I can't, for some reason I can't, oops, why did I delete it? Okay, so this pointer data is going to point towards this data, and this data is going to be pointing towards the new empty list. New empty list. So new empty list. Okay, so we want the previous data to point towards this new data, and the empty list is going to be updated to point towards the next one that's going to be stored in data. Right, so that's the idea that we're getting from here, and that's how the linked list is going to work. So we want to write the algorithm in that manner. So let's write here. So the name should be add node according to the question. It takes the linked list as parameter. So I'm going to again write an array since we're using an array as the linked list. And pointers as parameters. So it takes the start pointer as parameter. It takes the empty list pointer as parameter. And now it wants to says that it wants input. So the data to add is taken as input, and it should be an integer because that's what our linked list is. Then we want to go to input, and let's just write a suitable message. Enter the data to add. All right, so now what we want to do is if empty list is like if there's an empty list. So in this case, empty list is 5. If empty list is 0, that means it's not pointing towards anything. I mean, empty list is -1. Let's say it's less than 0 because 0 could be an empty list. Like the entire linked list is empty. There's no start pointer, there's an end pointer. Like it's starting from the very beginning. That's when empty list could be 0. So what we want to do is if empty list in this case, so it should be empty list pointer in my case, is less than 0, or empty list pointer is greater than, so in this case, the linked list has around 10 data, right? So 10 data. So what we want to do is 9 in this case for this particular linked list. So you could also use this following command of length of linked list. You could use that, but that's gonna just make it a little more difficult because it's a record data, I mean a class. So in this case, it's just better to put 9, making it easier for us. Then we want to return false because we know that the linked list is not, like you cannot add any more data to it. There's no more free list. Else, we want to go ahead and add the data. So first of all, we want to write, we want to first update empty list pointer. Okay, we want to update empty list point. Okay, before that, we want to go ahead and store the current free list. Yes, that's what I want to do. So free list is going to be empty list. And I'm going to tell you why we're doing this right now. Because we want, what do we want? We want this data right here. Let's turn this off. I don't know why these are showing up, but we want this data right here to point towards the new, like the next empty list. So in our case, that's going to be like The previous empty list was 5, if I'm not wrong. Yeah, 5. So this is where our new data is going to be added, because that's the end of the list. That's the empty list. From 5, we want to go ahead and move to 6. We want to store this value 6 right onto that empty list. Like, empty list should be updated to 6. So before we update this to 6, we want to store this value, because this is where we're going to be adding our data, right? We want to go ahead and add our data over there. So let's go ahead and just do that. So free list is going to be empty list, and empty list pointer is just going to be our uh, array. So that's going to be our linked list in this case. Array empty list pointer dot next node. All right. So we have updated that successfully. Now, what we want to do is, let's just say that, let's make a new node, a local variable once again. And over here, let's amend the data, which is data to add -1. Data to add -1. So this is, let's say, pointing towards, kind of nothing for now. Okay, because that's where kind of the list ends. We want to kind of do that. And we want to add this new node to the free list, where the list is currently free. So we want to say linked list dot, linked list bracket free list should be appended to new node. All right, we want to go ahead and add this, append this to new node. Now, let's go ahead and find the end of the list. Okay, so we want to find the end of the list, where the list ends. And the list would end where, there is a -1. This is where the free list ends, and this is where the list ends. Okay, this is where the list ends. So the question says that we want to add it to the end of the list. Let's go back to the question. So the function adds to the next, adds the node to the next available. Okay, sorry. So we want to add the node to the next available space, which is going to be, in this case, the end of the list. Okay. So the thing is, what we want to do is we want to go ahead and add it to where the 5 is. Okay, this 5 right here is. So before that, we need to find out where the list ends. So we're just going to kind of update the pointers accordingly. We want to find the end of the list. So let's go ahead and do that. So let's say the previous pointer is equal to 0. So so we want to go ahead and start pointer is that. So I want to also go ahead and write current pointer is equal to start pointer. That's a global one. I want to go ahead and use my local one. So while current pointer is not equal to -1, we want to do previous pointer is going to be changed to current pointer, and current pointer keeps getting updated to linked list current pointer dot next. So we want to go ahead and find out where that empty space is, where we want to go ahead and do that. Okay, so this is for, so what I'm going to add a comment to say this is for the empty space. Okay, so you're gonna want to slowly and carefully think about it a little bit when you are actually coding for the actual exam. Okay, so once that is done, then what we want to do is now update the pointers. Right, so this data over here, right, this data over here is going to be pointing towards the next empty list, and the previous pointer is going to point towards the new data that we're going to be trying to add. So I want to say that the linked list in this case, so in my case, I'm just saying linked list. This, I want to use the local one once again. I made a mistake again and again. So in my case, the array's previous pointer, okay, dot next node is going to be pointing towards what? The free list where we have added the data. So free list, right? Because now this previous pointer is pointing towards data. And as we can see in the free list, I've again said linked list, oh my god. So in the free list right over here, we've appended the new node. We've appended the new node. So once that's done, we want to say that over here, uh, empty list is already updated. So the previous pointer next node is going to be that. So it's added to the end of the array, right? So this is added to the end of the array, or in this case, the linked list. Right, so previous pointer next node is just going to be now pointing towards free node, and free node is where like the array kind of totally ends, and the empty list pointers is going to be telling us that where kind of kind of the next available, how much space is available in this linked list. Good. So and we've almost forgot, we want to return true, right? Okay, great. So with that being said, save the code. So we want to go ahead and take this chunk of the code right here and add it to our evidence document. Oh man, it's a big code, big chunk of code. But again, if you kind of practice linked lists before, it's an easy 7 mark. Now the question says we want to call add node output and appropriate match depending on the result of the add node. Okay. So call output node twice, before and after. So we want to go ahead and put an appropriate one, and we just want to we want to save the program. So they also want the code for this. So what we want to do is we want to say print before adding a node, and then we want to again go ahead and call output nodes. So let's just copy this, and I want to delete this because I don't need that anymore. Replace this. Then we want to go ahead and call up add node, but we want to take linked list as parameter. Then we want to take start pointer as parameter. We want to take the empty list as parameters. Okay. All right. And then we want to go ahead and call output nodes again. So what I want to say is print after adding a node, and then call output nodes again. So I think this much of the code should be enough. Let's go back to the evidence document and quickly update the evidence document and save it. Now it just has to test the program. Let's take a look. So 156, okay, 15. Oh, I forgot to clear the terminal since I'm using Visual Studio. This is before adding a note. So I want to enter the data to add. Let's look at the questions. It says take the value 5. So the idea I want to add is 5. Oops. Free list append, no attribute, array, free list. Okay, so I think we gotta change this. We can't use this convention in Python, so that's a little bit annoying. So we just want to go ahead and add new node like that. I think that should help. There you go, 5 is added. So clearly a nice output. In Python, we could use that convention if it was something like we didn't have this free list. If it was like that, then we could use array append, and then we could use it. But again, we can't use it in this convention, so I just had to correct that. Okay, so now they just want the screenshot, so paste the screenshot. Now again, you could just take the screenshot of this part, but again, it's better that you kind of prove to them that, yeah, I'm not cheating in any way, I'm not forging the output. Alright, so that's the entirety of question 1. A lot of marks secured. So let's go ahead and move on to question 2. So looking at the question paper, in this case, you can see that, oh god, so we have to store it in array data. Array data, write new program to write global data. Okay, so we want to save it as a question 2. So we want to right click, new file, question2.py. Question2.py. So we want an array, a global array, that array data, and it should be appended with these following data. initialize array data in the main program with the data values. Declare one day. Okay, so over here you can do it with comments, but the question specifically doesn't. But the recent years, all of them actually tells you that if you're using Python, you should use comments to declare attributes. So you could just use the pseudocode declaration, declare array data array of, so in this case, stores the following 10 integers, so it's going to be 1, 2, or since we're using Python, let's just be a bit more professional, of integer. Now you could use this Python convention of global, you could, but I personally wouldn't do it. So now we want to go ahead and store 10, 5, 6, 7, 1, 12, 13, I think that's what I saw, then 15, 21, 15, 21, 8. 15, 21, 8. Alright, so I think that's pretty much going to be it. Declare one the array and then initialize it with the data. Now let's go back to our Word document and paste it. A function linear search takes an integer as a parameter and performs a linear search on the data, right? So we need to just write a linear search algorithm, looking through each element of the array, and as soon as it finds one, then it's done. So def linear. Now you could make it efficient or you could make it inefficient, that even if it finds the data at once, it will continue to loop or it won't, so it's totally up to you. So in this case, linear search, if the function takes an integer as a parameter. Okay, so it takes a integer as a parameter. So let's just call that data to find. Now the array is global, so we must declare it as global inside the function. And then performs a linear search and returns true if it was found and false if it was not found. So let's include a local variable found false. Then for x in range, in this case it's a 10 length array, we want to go ahead and say if array data x is equivalent to the data to find, then you want to just go ahead and update found is to true. That's it. Otherwise, found is going to be always in false. Then exit the for loop and return found. That's pretty much it. So a very small code. For how many marks though? 6 marks. Very generous. But this is the first time the syllabus actually changed, so we can't complain. So it's gonna loop through the area until it's found. Now you could use it, like you could make it more efficient, like you could use a while loop while it's not found. But again, the question never mentioned us to write an inefficient or an efficient algorithm, so it's totally fine. Alright, so now the question says at the allow user to input an integer value. So let's name a value user input, alright? And then we want to take an integer input from the user. So input enter the data to find. Let's write that appropriate message. Pass the value to linear search, okay? And output an appropriate message. So if found, let's just call it if found is going to be the linear search result. So this is going to be user input. If found, which is if the condition is true, because this is going to be a Boolean value, so we could just use if found. Then we want to find print the value, what kind of output a program will user whether the search value was found or not. So the value was found indeed. If it is not found, which is that's going to be else print the value wasn't found. And I think that's pretty much it. We could copy this real quick and paste it just like that. Right? All right. So that's pretty much it. Test the parent program in the array to find that is value that is in the array and the value that is not in the array. So first of all, let's try with the value that's in the array. So let's say 6 is going to be the value we're going to be taking. So 6, the value was found. So in this case, we need 2 screenshots from. So this is going to be the first screenshot that we're going to be taking. And then we want a second screenshot with something that is not found. So, okay, there's a better way. What we can do is we can, just do enter the value to find. So we had 6. Then we want to run it again. And this time, let's use the value of 100. The value wasn't found. So this is the benefit of using Visual Studio. What we can just do is call it twice directly from the terminal. So we don't need 2 screenshots. Just 1 is enough. But again, even if you put 2 screenshots, there is no issue in doing that. It's totally acceptable. Okay. So the next part of the question states as that the following bubble sort pseudocode sorts the data in the array into descending numerical order. Okay. The array. Where is the array? This was array data. Okay, fine. There are 5 incomplete statements. So let's go ahead and try to complete this, right? So from 0 to, in this case, it's going to be, it wants to search all the elements. So in this case, it's going to be from 0 to 9, right? And in this case, it's going to be 0 to 8 because we want to kind of reduce the number of passes that we're going to do with the bubble sort algorithm. So in this case, they're using 2 for loops. Usually, this is more preferable with a while loop and a for loop, but again, it depends on how you totally do it. Totally up to you. Doesn't really matter. So if the array y is, okay, so okay, so this is interesting. So we also have to do it in descending order. Make sure you keep that in mind. So if the previous element is going to be less than, because we want to do the descending order, if it's less than the array, then temporary variable, the array, right? If it's less than that, then we want to put the greater than value. So this is going to be the array y plus 1. And over here, this is going to be 10. So once you've filled up the pseudocode, right? You've filled up the pseudocode. Let's go ahead and get to work. So we want to write def bubble sort. The question doesn't take any parameter. So for x in range 10. Again, the array in my case was global, so we're just going to write it as global for range 10. Then for x in range 9, or you could put it like this, like 0 to 9 and 0 to 8. It's totally up to you. It's the same thing. I'm just going to do it this way, but it's totally up to you. Then if array data, we want to take y, so y is less than array data, again I'm taking x, then what we want to do is in a temporary variable, which doesn't need to be declared at the moment, array data y, array data y is, so we want to change the value to y plus 1. That means we're appending it, and in array data y, y plus 1, we want to go ahead and put in the previous data. Was Python highlighting this as, oh, I put 2 x's. I didn't even notice that. Right. So that's pretty much it. and that's pretty much the algorithm according to my question. So I'm gonna go ahead and just copy this. Oh, they didn't ask for an output test for bubble sort. Really interesting. So didn't notice that. Okay. Finally, the last question of this paper. A computer game requires users to travel around the world to find open treasure chests. Okay, has a mathematics question inside. Okay, oops. Gonna make a game. The user enters the answer. The number of points awarded depends on number of attempts before the user gets the correct answer. So we're going to use object-driven programming in this case. It is given as the uh, kind of the parameters, I mean the instances inside this class, which is question answer points. Constructors is to take question answer points as parameters and creates an instance. We want to take every one of these as parameters in the constructors and kind of do that. So okay, so we're going to declare the class named treasure chest. Okay, hard work. So class treasure chest. Oops, I didn't put a bracket. Then inside this class, we want to make the constructor, so def init. So it takes the question, it takes the answer as parameters, and the number of points as parameters. And then now this is object-oriented programming, so we got to go ahead and put them as private. So if it's not private, then there's going to be an issue. We cannot force, because they want to also test that if you can force encapsulation or not. So we need to put them as private. It's a must. Now, Cambridge hasn't said anything that if you do not put them as private, how many points are they going to deduct? But you do need to put them as private. Oh, wait. Oh my God, I'm doing this inside the same. Oops, sorry. So you got to make a new text file because this is going to be question, obviously, 3.py, and just kind of put them in. And I also want to update the text file. Right. Uh, this okay. Okay. Let's look at the next part. I hope I'm still recording. Yes, I'm still recording. It's been 42 minutes. Damn. So we want to go ahead and look back at the question a little bit once again. Oh, there you go. The question even says that the attributes are private, so you must kind of take that into account. So the text file stores data for 5 questions in the order of points. Don't write any other methods. Okay. So this asks not to. So read data. Consider read data reads. Okay. As a get method, get question. Let's get question, check answer, get points. Oh, so we're going to append them later on. So for now, we don't need to write anything. So the next thing you need to write is read data. Right, so the text file stores it for 5 questions in the order of question answer points. Okay, so for 5 questions, we know how many. So this is the format of the text file, right? Question, answer, points. So write the program code for the procedure read data. Read each question, answer, and points text file. Create an object of type treasure chest. For each question, okay, we need to create an object. Declare an array named treasure chest of type treasure chest. Okay, array treasure. Append it, obviously, to the array and output the message if file is not found. So if the file is not found, we want to output appropriate message. So first, let's declare the array, which is going to be array treasure of treasure chest. So that's this. Okay, so now we want to put in an exception handling, except IOR. That means the file is not going to be found. So print The file is not found. And inside this try handle, we want to go ahead and try to open the file. So you want to first read the file, just treasure chest data.txt. Now, since I have the PDF of the question paper, I'm just going to copy this to ensure no errors. So file, open, and you're opening this file to read the data. So let's put a variable question file dot read line, and we use strip to go ahead and remove any blank lines, or the blank lines that's in the file. Because if you go ahead, which you are allowed to do in the exam, if you open the question paper and we go to the text file, right, you can go ahead and you can see kind of like this is how it's. So everything is in a new line, so you want to omit that new line, right? Okay, so question answer is also going to be file dot read line dot strip, and the points is going to be file dot read line dot strip. Now we want to read every single line of the file for the 10 questions, obviously. So let's go ahead and copy this. Now let's remove this for a second. And so we know that there's going to be exactly 10 data in the file. So we can use this. We don't need to go ahead and check if the file is empty. We know that exactly this for 10 games, right? Sorry, not 10, I think. How many? Like the question, I think, stated. 5. Sorry, 5. Right? So we can go back to the code editor, 5. And then paste in our details. Let's just put the indentation. And then we want to create the question object, right? So let's just call that game object. And then let's create the instance of the object, which is going to contain question. It's going to contain answer. And it's going to contain points. And then in the array treasure append, so right now we can use the append object that we couldn't use before because we're not using it, right? And that's pretty much it. I don't think they want anything else from us in this question, right? So this is pretty much it, right? So this is pretty much it for the first part. Let's move on to the next part. The main program repeats each question until the user input is correct. The number of points over depends on the number of attempts before the user gives the correct answer. So it says get question, returns the question. So we want to write the get method. So def get question. Obviously, this is we have force encapsulations. We need to put private return, self dot question. So let's just copy the whole code because we're amending the class itself. So it's going to be part 3 1. Put in that. Let's see what it wants next from us. The class check answer that takes the user's answers parameter, returns true, answer returns false otherwise. So return check answer. Okay. So this it says the class. Yes, it's going to this is def check answer. So it takes the user's answer as parameter. So I'm just going to name it user answer. So if user answer is equal to self dot answer, Then we want to return true, else return false. So we copy the code for the entire class again. Now, if you just copied the code for, the function, then you are also going to receive marks. It's better to copy the entire thing, but you don't need to worry if you didn't do it during exams. But I mean, who's giving exams in 2021 anymore? All right, so with that being done, now let's move on to the next part. The class treasure chest has a method get points that takes the number of attempts as parameters. Okay, so the number of attempts is 1, it returns the value of points. Returns the value of points. If it's 2, then the integer is divided by 2. So div 2, we need to do div 2. If it's 3 or 4, if returns div 4. Is not 1 to 3 returns 0. Okay. So let's go ahead and code that. Oh man, this is a huge question. All right, so with that being said, so let's go ahead and write def get points and self user attempts. Why is there a treasure highlighted? Oh, okay. Let's ignore that for now. What if we just pass? Oh yeah, okay. It's an issue with the code. So we want to see first if user attempts is equivalent to 1, return self points. We just went directly, if the number is return the value of points. Else if user attempts is equal to 2, return self dot also points div 2. So this is the div operator in Python, and I want to just put in a brackets just to be safe. Elif user attempts is equal to 3 or user attempts is equal to 4, then what we want to do is we want to return self dot points div 4 according to the question. So div dot 4 finally, else if none of them is true, then just return 0. Now again, we want to go ahead and choose the entire treasure class and just go ahead and paste it just like that. Save it. Oh, and also remove the italics. They prefer it that way. All right, let's see what's the next part of the question. Call the procedure read data. Ask the user to enter number between 1 and 5. The question that matches the number entered by the user. All right, so first we want to go ahead and call the procedure. So first we want to call read data. Okay, so I made a mistake. What's the mistake? This was a procedure read data, but me being too smart, I didn't put it inside a procedure. So let's just go ahead and cut this. Read data. Let's just put that as global. Try. And now we got an indent. I mean, I like that thing about PyCharm where they auto indent, like uses an AI or stuff like that. Yep. So let's update this code. This was question number B. A dot B. Paste this. All right, so read data. So it first reads all the data, obviously. Then the user chooses the question. So question choice, int. Oh, sorry. Input, enter the question number. Then we want to go ahead and call in the methods, appropriate methods. So okay, U215 ask like outputs a question that matches it. All right, so thus the question is going to be array treasure, question choice. We want to get question. So right, yeah, array treasure, get question, get question. So we want to go ahead and do that. Okay, now the thing is the question numbers start from 1, right? This is the trick here. The question starts from 1 to 5, but array indices start from 0, so it's 0 to 4. So in this case, we need to amend question number in such a way, question choice in such a way. So this should be question choice minus, this should be question choice plus 1. If you do plus 1, it's going to be actually, so we want to do minus 1. So if you, let's say, I've input the number 5 here, right? I've input the number 5. But in the array indices, that's from 0 to 4. So in this case, that's going to be like, in that case, we can say that 5 is equivalent to 4, right? Because this is the array index that we're talking about. So we need to do minus 1 over here, all right? If that's clear. Then I want to go ahead and print question. So then we want to go ahead and check the answer, if it's correct or not. So the answer, all right, the answer is going to be input, enter the answer. Okay, and number, we also want to check the number of attempts, which is going to be equal to 0. And correct, oops, is going to be another local variable that's going to be initially false. So while not correct, well, the answer is not correct, we want to say that we output the, like, re-enter the answer, and number of attempts is going to be plus equal to 1. So we want to kind of go ahead and increase number of attempts. And this should be under an if statement. So if answer is equal to, we've got array treasure, question choice minus 1, and we want to go ahead and get the answer. So this is a check answer. This is a check answer. Oh, so we already have the method for that right here. We have checked it. So while not correct, so let's just call it check answer. And then I'm gonna put the array treasure, question choice minus 1 dot check answer. If not check answer, that means the answer is incorrect. Then we want to increase number of attempts, and we also want to repeat uh, this exact same statement once again, right? We want to go ahead and repeat this. I think that's pretty much it. And then we want to go ahead and print the score. He's about to get points, the number of points awarded, output the number of points the user got. So score is going to be question, array treasure, question choice dot one. What was the method again? I forgot. Get points. Get points. And print the user score is this. Or the question says points, let's just points. Is this. Then comma score. All right, so this is pretty much the logical parts. So every year, the questions are in object-oriented programming, reading data and file handling from the text file, obviously, and one logical question. So in this case, this would be a logical question. And obviously, we want to go ahead and do the output test. Select question 1 and answer correctly the first time. Select question 5 and answer correctly the second time. So they're specifying us when to answer correctly and when not to. Let's see. Question 1, 2 times 2, 4. Okay, missing one user answer. Okay, user answer is missing. Oh, so check answer is going to be answer. And oh, oh my god, so correct. Not here, not here. If not this, then this. Else, correct equals true. Okay, get points. User attempts. I also forgot there's a number of attempts. So we want to put number of attempts in here. Thank God. Okay, so question number 1, it reads it correctly. The answer should be 4. The user's point, okay, it's giving me an output of 0. Why is that the case? It shouldn't be giving me the output of a 0. So user attempt is 1. Oh, so we want to go ahead and start off with 1 because that's going to be the very first attempt of the user, right? So I think that's the logic here. 4. There you go. The user's one is 10. And I want to answer correctly the second time according to the question. So the question has asked me to take number 5. Question number 5. 3,000 was the answer should be 7,000. I'm going to enter 5,000. It asks me again, so I'm going to enter 7,000. This okay. Unsupported. Oh, okay. Okay. Got it. So this should be, since I'm reading a text file, it should be int. Okay, now let's rerun it. So like this question 1, 4. Okay, great. Question 5. Oh, okay. Sorry, I need to rerun it. So question 1, 4. Then I'm gonna rerun question number 5. Let's enter 5,000. Now let's enter 7,000. The user's point is 9. Okay, I hope that's the correct one because I'm not checking the mark scheme. Again, I Control-Shift-S. Okay, and I'm going to take the screenshot of it. And that marks the end of the paper. And I'm also going to go ahead and export this evidence or doc file and attach it at the description of this video, so that if you don't want to refer to the mark scheme, because I've done a little bit differently than the mark scheme, if you don't want to kind of like refer to the mark scheme but want to refer to how I did it a little bit differently, you can very much go ahead and do this by looking at this code, or since it's difficult to share the Python files themselves through Google Drive, so I'm just going to go and do that. With that being said, thanks for watching. Peace.